All right, welcome. In this video, we're going to review the answers to a practice quiz that is a practice quiz on the angles and the areas of polygons. And basically, it's about the interior and exterior angles of polygons, and then our method of finding the area of a polygon by breaking it into triangles. So let's get into these three questions. The first question, the measure of one exterior angle of a regular polygon. Oh, I hope this is correct. This should say interior. The measure of one interior angle of a regular polygon is 176 degrees, which means it will have quite a few sides. How many sides does the polygon have? And then here are just some discussion questions that we may discuss in a moment. But let's do this problem right away. So if the interior angles are each 176, then what that means is that if you started to sketch this polygon, it would look something like this. Each angle here is 176. And then the question is, of course, how many sides does it have? So n equals how many? Well, there's two different ways to do this. One way is to create an equation using the n minus 2 times 180 formula. And another way is to use exterior angles. And since the sum of exterior angles for a polygon is always 360, you can just use that fact. So let's explore that. What you would do is extend this line here, and you could extend it here and here, and what you'll see is that here are the exterior angles. And I hope it's clear to you that the exterior angles would each be 4 degrees. And that's, of course, because together the interior and the exterior angles in this scenario sum to 180. So this little red angle, the exterior angle, has to be 4 because 176 subtracted from 180 is 4. And together, the exterior and the interior angles are on a straight line. So what we essentially just know is that each exterior angle is 4. And so if each exterior angle is 4, how many sides are there? Well, in total, the exterior angles add up to 360. So if you know how much something adds up to, and you know how much each one is 4, well, just divide. 360 divided by 4, and what we're going to see is that there are 90 sides. So the polygon has 90 sides. Okay. There's a quick discussion question here. Why is it important that we say regular? Well, of course the word regular is so important here because regular for a polygon means all the angles and sides are the same. And that's what allows us to say that all these angles are 176. Otherwise, this polygon could be twisted around and it wouldn't even make sense. One angle is 176 means all the interior angles are 176 because regular means equilateral, equal sides, and equiangular. Okay, second question. Here it says we got a polygon, 1, 2, 3, 4, 5, 6, 7 sides, and it says create and solve an equation that can be used to solve for x. There we go. Create and solve an equation for x. So how do you do this here? What happens? Well, I hope you see that we're looking at interior angles. There's 7 sides, and there's very well 7 angles in here. And so the key thing is that, well, if there's 7 sides and they're interior angles, we can find the sum of all these angles, and then we can just add them up and equal them to whatever it's supposed to be. So let's find the sum right now for 7 sides. So the sum is going to be the formula n minus 2 times 180. And I just wrote sum, but what I really mean is the sum of all the angles on the inside. So we already talked about, hey, there's 7 sides. That's why I was interested in counting those 7 sides at the beginning. So let's use the formula to find the sum. 7 minus 2 times 180, and we're just using the formula to find the sum of the angles. So that'll be 5 times 180 from subtracting first, and then 5 times 180 is 900. So what that means is that all these angles sum to 900. So now what we can do is we can just do a little bit of algebra and say, okay, let's write a big equation, all these added together, and I think what I'm actually going to do is put these, shrink them move it over, because it's dawning on me that we actually need quite a bit of space to make this equation, just because there's 7 angles. So here we go. Let's do it. I'll do another color. So we'll say x plus 18, first angle, plus 132, plus 130, plus 130, plus x plus 10, plus 138, plus the last angle x. And what will this sum equal to? Well, of course, it will equal to 900. Oh, you can't see that. Let me move it over one more time. So this sums to 900 because the angles sum to 900. So now it's just a matter of solving this equation. But the key thing you want to see is like, okay, what's really happening? There are 7 angles in this polygon that has 7 sides, called the septagon. There's 7 angles. They all sum to 900. So we say all these things added together equal to 900. And then we just solve for x. And hopefully this is easy, just combine like terms. So we see that there's 3 x's, so there's 3x. And adding up all these numbers on a calculator, I think if I hit this button, there you should see, I actually summed up already. Here are the whole numbers that we're adding up, 18, 132, 130, 130, 10, and 138. Sums to 558. So just finishing this work, 558 plus 3x equals to 900, and now we solve. So hopefully this is really simple. We subtract 558 on both sides, and we're going to see that 3x equals 342, and then of course we divide by 3, and we get x equals 117. Okay, cool. X is 117. And that is the measure of x, that if, what's the concept is that if you put this value of x right here, so like, for example, this angle that I'm labeling would be 117 plus 10, 127. You could do the same for the other unknown angles. And then you add up all those angles, you should get 900. And the equation does the beautiful algebra work for you. Okay, let's do this last question. Now this last question says, let's actually move this to the next page. Okay. Pictured below, a regular decagon has side lengths that each measure 8 centimeters, making the perimeter 80 centimeters. Of course, because there's 10 sides. What is the area of this polygon? Well, this is really going to take a little bit of our thinking, and hopefully this is really easy for you because we've reviewed super similar questions in class. But I know also it can still be tricky because there's quite a few steps. So let's really try to clarify those steps here. The first thing you want to do is cut this imaginarily speaking, cut this into triangles. So like a pizza, we're going to cut this into 10 triangles. And then the area of this whole polygon is going to be 10, and then the area of each triangle is 1/2 base times height. So this whole polygon is just 10 triangles. Now let's put this to the side. Let's move that over here. Because to do this, we have to find the base and the height for each triangle. Well, of course, right here is the base. And I hope it's really clear to you that the base is 8 because all the sides are 8, because that was just given to us in the problem. Each side measures 8 centimeters. Okay, so we could actually even start to do this work. 10 triangles, 1/2 base times height. The base length is 10. But of course, what's unknown is this height right here. What is that height? Well, let's solve for it right now. And to find that height, what I did in class and what is hopefully helpful for you to see is if you draw one triangle separately. So let's do that, and then let's drop down the height. And just drawing it separately helps you see it. So once you see this one triangle, all right, here's the base, the 8 centimeters that we know. Here's the height that we're looking for. What's that height? Well, what's the strategy? The strategy is to use trigonometry. So first thing you can realize is that height drops down and cuts the triangle in half. So that base that's 8, that gets cut in half. So that base, just that half of the base is 4. And then I'll outline this rest of this triangle in orange. So I'm really only taking half of the triangle for the moment because that's going to allow us to use trigonometry with this right triangle. All right, so that piece is 4. We're looking for the height. What's the height? Well, of course, to use trigonometry, we need an angle measure because that angle measure really defines like a doorway how open something is, and that lets us calculate and solve for missing lengths. So what is that angle measure up at this top corner of the triangle? Well, that angle is just like the sharp corner of one slice of pizza. What is that angle right there? Well, the angle right here, I hope you see, well, that could be just considered to be 360 because, of course, in the center we have 360 degrees, and then it's just divided by 10. So 360 divided by 10 is, of course, 36. And then this angle that I'm pointing at right here, that I'm actually going to erase and point at in orange just to make it really clear, this angle right there, that same angle, will just be 36, but cut in half. Half of 36 is 18. So that angle is 18 degrees, and that's the angle that we're going to use in our trigonometry. So now when you're using your trigonometry, of course, the first step is to label opposite, adjacent, hypotenuse sides. So across from this angle right here is the opposite side. So the 4 is the opposite, the h is the adjacent, and then this side over here that's not labeled, we're not using it right now, but it's the hypotenuse. So now we're going to say opposite 4, adjacent is the height we're looking for. Our angle, our reference angle is 18. Well, let's find the height using trigonometry. Here we go. So how would you use trigonometry? Well, you would think opposite and adjacent. And if you don't remember, you can use SOHCAHTOA. And as you can see, opposite and adjacent appears in the tangent ratio. So we're going to use a tangent, and we're going to say the tangent of 18 equals the opposite side 4 over the adjacent side h. And now we solve for this. So of course we have to pull up our handy calculator, and first thing is we're going to look up what's the angle of the tangent of 18. So the tangent of 18 degrees. Oh, it said, that's interesting. Desmos thought I was timesing. I must have hit the times button. The tangent of 18, no dot, just tangent parentheses 18, is 0.3249. So then we come back here and we say that this is 0.3249 equals 4 over h. And now we just solve for the height. So I'm going to times both sides by h to eliminate that. And I'm going to get that 0.3249h equals 4. Then we're going to divide by this decimal 0.3249 on both sides. I should have done the division in red, like how I multiplied both sides in red. Oh well. H equals 4 divided by 0.3249, which, coming back to our calculator, is 12.31. So that's an important number, because what does that number represent? That represents, I gotta look at it again, 12.311. 12.31, that's an important number because what that represents is, of course, the height. That unlocks the problem, and that allows us to say, okay, now we can find the area of one of these triangles and then times it by 10. So let's fill it in. So this 12.39, not that you really need it, but it's gonna, this green highlighter shows you where it's gonna go. It's gonna go right there. And so this will be 12.31, and now we just multiply. So the area will be 10, and then let's multiply. I'm going to do 0.5 times 10 times 12.31, and the 0.5 is, of course, this 0.5 right here is because that's the same as a half, and that's the easy way to multiply by a half, is to multiply by 0.5. So that comes out to be 61.55. Now I've made a mistake, and I'm so glad I just caught this mistake. I'm turning off the calculator. Let's fix this mistake. Can't believe I've done this whole time. This 10 is not 10. There's 10 sides. But what does that B stand for? That B stands for the base length. And I hope in your head this whole time you're thinking, oh, I hope Naftalin corrects this. Right, the base length is 8. So of course this should be 8 right there. And now let's go back to our calculator and put in, 8. All right, so what that means is that the area of each triangle is 49.24. And then there's 10 triangles, so 10 times 49.24 is 492.4. And that's the area of this polygon. It's 10 triangles. The base was 8. The height was 12.31. And we found that height using trigonometry. So I hope this is helpful and clear for you, and I hope you're ready tomorrow. Now, the last thing I want to mention about this is that what if we had a similar polygon, and actually I think I can just take this and copy and paste it down here. Cool. Let's take a look. What if I had the similar polygon, but instead of saying the base length was each 8, what if I gave the information that this length was 8? How would you do that? Well, you'd still cut it into triangles, but the one thing you really want to realize is that that 8 is the hypotenuse of one of your orange triangles. So you would have to then find this piece x and the height, and then of course remember to multiply this piece x times 2 to find this whole base length. And how would you find x? Well, you would use your same angle here, but you would use a sine. So you'd say like the sine of this angle equals x over 8, because sine is opposite over hypotenuse. And then to find h, you could use a cosine and say the cosine of this angle equals h over 8. You could also use the x you just found and use a tangent. So be aware that when using this method of breaking a polygon into triangles, it's not always going to be a tangent that you use to find your missing height or your missing base. It depends on what information is given to you in the triangle or given to you in the polygon, which becomes one part of one triangle. So I hope this was helpful. Please send me messages if you have questions. Adios.